Okay, so good afternoon, class, and please take out your textbook and please turn to page 123. Now, today I have some personal issues, so I could not come back to having lessons with you. So therefore, please, I've recorded this video so that it will not bother our teaching schedules. So today you will have two things, okay? You need to work on it. First, I need you to have your notebook ready. Okay, because later on I would like to mark down the notes with you so that you can do the revision at home. Now, the second things would be I will distribute back to you the workbook. For the workbook, you will have the homework, okay, which is due on Wednesday, which is tomorrow. So please help me to complete the part, which is the 5.2, the conduction, convections, and also the radiation. Now, uh, for today's, okay, I would like to continue to talk or recap on convections with you first. And then we will go through about slightly, okay, related to the radiation. And then, okay, we will do some question on it, on these two ideas, and we will have a notes, okay? And the notes, in fact, the format of the notes, it will very similar to your dictation on Monday. So therefore, sorry, on Tuesday. So therefore, please, okay, sorry, not Tuesday, it should be Wednesday, okay? It will be very similar to the dictation on Wednesday. So please, okay, mark it out for your reference to do the revisions. And thirdly, I will debrief, okay, the part that I've already marked at, okay, which is 5.1 with you. And I will also distribute the homework, okay? I mean, I will also mention about which pages that you need to work on it. Is that okay? Now, um, last lesson, we have mentioned about the convections. It is a type of heat transfer process mainly, okay? We are mentioning about how the water flow in the liquid state, okay? I mean, how the liquid moves, okay? With when we apply the heat or how the heat transfer within the liquid state. And also it would occur, okay, in the gas state, okay, which means that how the air particle moves. Now, basically, the first idea would be once we apply heat to that area, either the water particle or the air particle will move upward. Okay. So once it moves upward, then in this case, that area, it will be nothing, right? So in this case, how can we do? So the cold water or air will move in to replace the hot air. So therefore, okay, uh, this is how the convection works. So this will create a current, okay? Now, for example, okay, when we try to boil, okay, the the water inside the electric water kettles, then in this case, okay, we're trying to apply heat to it. Then as the inner part it has a higher temperature, then in this case, there will be a rising, okay, of the water molecules or the water particles. Then in this case, once it goes up, then it will move, okay, to the colder part because the colder part of the water particles will replace, okay, those raised, okay, water molecules. So this create a water current, okay. Now, the same thing happening for the sea breeze and also the land breeze, okay? So why will we have the wind? Because of the warm air. The warm air will go up, rise to the sky. Then in this case, it will migrate or move to the colder part because the colder part, the cold air, it will be replacing the hot, the rise hot air. or the warm air. So therefore, okay, we will see there will be a movement of air. And in this case, this will create the wind. And if the wind comes from the sea towards to the land, then in this case, we will say it is the sea breeze. If, okay, it is from the land towards to the sea, then in this case, we will say it is the land breeze. Now, we have the idea of how the convection works, okay? And it is important, we will see that, in fact, the convection, it will be affected by the position of the heat source. If we try to place the heat source at the downside, then in this case, the bottom of the test tube, then in this case, they will have a longer, okay, convection. The convection, it can occur to all the water inside the test tube, then it can heat up all the water. But, okay, if, okay, the heat source only occur in the surface of the water, then in this case, okay, the heat water will be stay at the top and the water at the bottom, it will not be being heat up. It takes a lot longer time for the bottom of the water to heat up. And this is also why we were applying the convection. For example, we will install the convection heater at the bottom part because it can warm up, okay, the whole room by rising or by having an upward movement of the warm air. So therefore, once the warm air move up, so this can make the whole room, okay, warm. But if we install it in the above, okay, then we will only let our ceiling warm, but it will not let our floor also warm too. Okay, so therefore, okay, it would be better for us to install the convection heater in the floor rather than in the ceiling. Now, on the other hand, for the air conditioner, okay, the air conditioner we will install it in the ceiling rather than we will install it in the floor. That is because the air conditioner normally we will blow out some cold air. So therefore, okay, the warm air will rise. Okay, this will force the ground floor, the air become warmer. Okay, so in this case, the warm air it will rise so that it can replace okay the cold air. So in this case, what happened? Then this will let the whole room become cool. Now, the same thing, okay? In order for us to slow down the convection, we will have different practice. For example, we will setting a greenhouse so that the air warmed by the sun will trap inside the greenhouse. So this can keep our whole greenhouse warm in the cold weather. Now, last lesson, we have also go through about the direction, okay, of the thermal energy by the convection, okay. Now, what I want you to do, I want you to complete the quick check on page 126, both from question 1 to question 4, okay. I will give you 3 minutes to complete it, okay. Okay, now the times fly, so I assume you have already completed, okay. Now, convection, it will occur in solid and liquid and also gas. Okay, so in this case, what do you think? Okay, uh, in this case, you will see that, okay, in fact, convection, will it occur in solid state? Definitely, it will not occur in the solid state. Okay, so therefore, as it will not occur in the solid state, so therefore, the statement of the first statement, in fact, it will be false. Now, the second part, the second question, in fact, the thermal energy is transferred all direction by convection. So is it all direction? So you need to think about it, okay? Is it will go all direction, or it has a desired direction? In fact, it has a desired direction. It will not go in all direction, but it will go in one direction. For example, the heat thermal energy, it will cause the warm air to go upward, but not going to the rightward or the leftward, or it will not go downward, but it will only go upward. So therefore, it is not transferred in all direction. It transfer in particular direction. Is it clear? Now then, okay, we will have the third question, which is the airflow. So whether the air will flows when it heated. Definitely the air will flow because it will flow upward, okay, move up, okay, so once it heat. Then the first statement, the heating part of an electric kettle should be fixed near the bottom to facilitate the convection. So in this case, the heating parts of an electric kettle should be fixed near the bottom, okay, so that it can facilitate, okay, the convection. This is because, okay, if we locate it on the above part, then in this case, it is difficult for the water to undergo the convection. So therefore, we need to install it at the bottom so that the warm water can move upward. So this can bring a convection current, okay? Now, we'll move on to the radiation, okay? Now, remember, radiation, we are referring to the heat transfer through a vacuum. So, meaning that no matter in what condition, we will have the radiation. So, the practical here and also the videos that I record, you will see that no matter there is any cardboard or any things. In fact, the first thing that's the heater or the radiation or the thermal energy arrive to that object, it will already heat up the object. Okay, so we will say these types of transfer, in fact, it is what we call the radiation. Okay, the thermal energy is transferred directly from the heat source towards to the objective, or the not objective but to the object. Okay, even though there is a vacuum, it can still transfer. Okay, now for example, when we are doing the barbecue, okay, then you will realize that even though we did not touch the fire, we can still feel the heat. That is because of the radiation from the fire. So the radiation, it can occur in any space, including the vacuum. And the thermal energy is transferred directly from the heat source towards to the object. Now, we'll realize that, okay, the color of the object, it will also affect the radiation. Now, in this case, we will say if the object, it can absorb, okay, the thermal energy by radiation, we will say that it is the absorber of the radiation. Then most of the dull black color, it will have a better absorber and also emitter of the radiation. But on the other hand, shiny and light colored object, it would be poor, okay, absorber and also emitter of the radiation, as they emit the thermal energy and also absorb the thermal energy. Comparatively, it would be not that good when comparing to the dark black colored. So they will reflect away the thermal energy. So therefore, they are a worse, okay, they are a bad absorber or emitter of the radiation. Okay, so now, okay, Marcus, can you tell me, okay, what would be the dark and black colored objects? They are a poor or better absorber and emitter of the radiation. Okay, so it should be the better one. okay, better absorber and emitter of radiation than the shiny and also the light colored objects. Okay. Now, okay, we will have different applications for the radiation, but maybe I will not go through with you. You can watch the videos and see it. Now, in most of the exam or uniform tests, or I mean the quiz, okay, we will ask you about, or we will give you a scenario and ask you whether these component, how it can reduce the heat transfer. It can be either help reduce the heat transfer by the conduction, by the convection, or by the radiation. Then in this case, okay, we will see. For example, now we have the vacuum flask. Now, if we need to think about, okay, the vacuum between the double wall, how can it reduce the heat transfer? Is it reduce the heat transfer by radiation? No. Why? Because if it reduce the radiation, then in this case, we will notice that in fact the radiation, it will still occur inside the vacuum. So therefore, it must not be reduce the heat transfer by radiation. Now, in this case, I use Cantonese to mention about it. 嗱，咩意思咧？就係我哋好多時候咧，我哋會俾一個 scenario 嚟嘅。嗱，呢一個嘅 scenario 咧，佢係即係通常我哋會用啲家庭嘅一啲用品啦。咁而呢啲家庭嘅用品咧，就會問你啦，究竟佢點樣可以咧去減少個 heat transfer by conduction、by convection 定係 by radiation 咧？嗱，如果舉個例子，我用 vacuum，OK，即係真空嘅狀態 between 個 double wall，咁我哋就會發現咧 radiation 咧其實咧係唔應該係去即係有一個真空嘅狀態咧就會 reduce 咗嘅。相反，佢其實咧仍然都會能夠傳遞得到。咁所以就應該係其他嘅嘢咧係 reduce 咗個 heat transfer 嘅。咁邊啲啊？舉個例子啦，就係 conduction 同埋 convection 啦。因為 radiation 咧，佢仍然能夠咧透過真空嘅狀態嘅情況之下咧，佢都仍然能夠係傳遞咧個 thermal energy 嘅。但係 conduction 同埋 convection 咧，佢係唔可以嘅。咁亦都衍生出咧，呢一度我哋就一定要去做一個咧整理啦。We need to tidy up what we have learned. So now, please take out your notebook so that I can revise with you by help you to mark down some important key points so that you will easier for you to do the revision. Now, please take out your notebook. So last lesson, we have already go through about the conduction. Okay, we have already marked down the definition, the notes, okay, for the conduction. Then how about for the convection and also the radiation? So I want you to formulate a new table, okay, so that you can see, okay, how the conduction, convection, and also the radiation different with each other, okay? Now, this time, okay, let us have a look on the heat transfer. Now, for the heat transfer, okay, we have the conduction. We have the convection. And then we also have the radiation. Okay. Now, when we have these three types of heat transfer method, then you will see okay, you will realize that, okay, we have several states, solid state, okay, liquid state, gas state, And then lastly, under vacuum condition. Now, for conduction, can you tell me, can it occur in solid state? Yes, it can. It is occur the best comparing to other states. Now, it can still occur in the liquid state, but sorry, it will be a lot slower. Then how about gas? For gas, it would be the slowest. Okay, but can it still occur in vacuum condition? No, it cannot occur in vacuum condition. 真空狀態，OK。Okay. Now, then we have the second one, okay, the convection. Now, convection, it will not occur in solid state, but it will occur in liquid state and also the gas state. But, okay, it will not occur in vacuum condition, okay? Then radiation, it will occur in vacuum condition, okay? But it will also uh, conduct in solid state, liquid state, and also the gas state. So meaning that all the states, okay, it will also occur the radiation, but just, okay, it also occur in vacuum condition. Now, for the definition of condition, we have already mentioned it. Then in this case, conduction, I will skip it, okay? So you can just write it down from the previous part, okay, about the definition. Then we will move on to the convection. Now, what is the definition of convection? If you have a look in your textbook, in fact, there are two main ideas for the convection. Sisi, can you tell me about it? For the first one, what is the first definition or the first idea for the convection? So the thermal energy, it will transfer upward, remember, okay? So the thermal energy under the convection condition, okay, our thermal energy, it must be transfer upward, okay? It will not transfer downward. It will not transfer leftward. It will not also transfer rightward, but it will only transfer upward, okay? Then the second idea, so it will be the cold air or water will replace the hot the empty space, okay? Okay, so basically the cold air or water will replace the empty space. That's the uh, hot air or the water that has been moved upward, okay? Okay, then how about radiation, okay? For radiation, it will also have two important definition or two main idea for the definition. Okay. So the radiation, the first idea. The first idea will be it can occur in vacuum condition. Then second one, okay, apart from it can occur in the vacuum condition, but also, okay, it will transfer the thermal energy directly from the heat source to the object. Okay. Now we have this idea. Then in this case, okay, we have already go through three types of heat transfer process. Okay. Oh, sorry. There should be one more idea for the convection. The convection, the effectiveness, okay, of convection is depends on the position, okay, of the heat source. Okay. So for convection, there are three ideas, while for radiation, there are two. Okay. Now, we do not have any convector, okay, for convection. So we no need to think about, oh, whether there is any good convector, bad convector, etc. No need, okay. But what you need to learn or what you need to think about, which would be our um, emitter and also absorber for the radiation. Now, for radiation, you will see there are two types, okay? Normally, we will say that there will be absorber of radiation and also the emitter of radiation. Now, if we are talking about both good absorber and emitter of radiation, then in this case, we are referring to the dull and black color. Then for those that are bad or worse, okay, then in this case, it would be the silvery, shiny, light color, okay? So poor absorber. It would be silvery or light. Okay? Or maybe you can use another term rather than silvery, okay? We maybe use shiny, okay? Shiny and light colored object, okay? So basically, we will use the color to determine, okay, whether it is a good absorber or a poor absorber and emitter of radiation. Now, we have already go through the notes, okay, the handouts, okay. Now, for these, okay, I want you to do some revision at home, and it will be exactly the same that um, when I ask you for the dictation. So I will tell you more details during the CTP on Wednesday. So don't worry about it, okay? So, but please, okay, revise, okay, based on what I've written down here, okay? Now, then, uh, you have this idea. What I want you to do, I would like you to complete, okay, page 132. Discuss with your friends, okay, or the neighbor. Help me to complete, okay, and see whether this component can help to reduce the heat transfer. Is okay? Then afterward, okay, we will check the answer of the workbook. Okay, so I think you have enough time for the discussion. Now, for cover, can you tell me whether it can help to reduce the heat transfer by which process? Okay, so we're having a cover. The cover, in fact, it tries to create a convection current. So therefore, it is related to the both conduction and also convection. Now we have some insulated support. Okay, so insulator. So this must be related to the conduction. Okay, the color of the silvery glass wall. Then in this case, silvery meaning that it would be related to the color. Then this must be related to the radiation. Okay. Next, okay, the outer case which is made of plastic. Plastic, what types of material it is? It is an insulator, but not conductor. So therefore, it is also related to the conduction. Okay. Now, when we have a look on it, the vacuum flask can also keep the ice string cold. So how can we explain it? Okay. It can be explained by in this way. Okay. It can keep the ice string cold because it slow down, okay, the um, transfer of thermal energy from outside to the eye string. Okay, so this can help the eye string hold. Remember, we are not trying to gain or speed up the transfer of uh, cold energy. We do not have cold energy. We only have thermal energy. So if the things it can keep cool, then in this case, we are just trying to slow down the transfer of thermal energy. Is okay? So for this part, what I want you to do is to help me to complete it at home or maybe during the lessons, okay? I will check the answer with you next lesson, okay? So please help me to complete it. I will check uh, who, okay, did not do it. If you did not do it, I will mark it down on your handbook, okay? So as you missing the things, then you may receive a warning about it. So please help me to complete it for this one. Now, then I would like to move on to the workbook. Okay, so please the monitor and also the subject leader, sorry, not the monitor and also the monitors. The subject leaders, please help me to distribute the workbooks to the students. And I would like to check, okay, the previous homework, okay, which is 5.1. Now, uh, okay, so for the workbook, okay, uh, most of you done a great job, okay, but some of you have been confusing, okay. Uh, the sun, oh, it will give out solar energy. Yes, okay, it will give out light energy. But remember, we were not saying that the light energy as the solar energy I've mentioned a lots of time. In uh, primary school, you may learn that, okay, the light energy or the solar energy, in fact, it is referring to, the solar energy, in fact, is referring to the light energy. But when you go up to secondary school, in fact, the solar energy is somehow different from the light energy. So the sun, it will give out the light energy and also the thermal energy. Now, when we're hitting the drum, okay, the speaking and also speaking and singing, in fact, we're trying to give out the sound energy, okay? The television set, it obtained electrical energy, okay, from the power station, okay? And a spring, okay, it will gain the potential energy when it compressed, okay? Fuels and food stored, in fact, it stored the chemical energy. Now, next, okay, the light energy is directly converted to the electrical energy by a solar cell. Many of you just write down solar. Solar in English is referring to the sun. How can you connect the light or how can the light energy converted to the electrical energy by a sun? It is impossible. So it is by the solar cell 太陽能板就唔係咧太陽。Okay, so you're meaning different things, so don't be lazy. Now, a dry cell store electrical energy. So it is not storing the electrical energy, but it is storing the chemical energy. Okay, so once the dry cell connect to the wire, then in this case, it will supply the electrical energy. So it is somehow different. So the faster the ship moves, so the more kinetic it has. So yes, it is, okay. A lift gained potential energy when it goes up, okay? So in fact, a lift, it will gain, okay, the potential energy when it go up because the higher position it has a higher potential energy. Next, the electrical energy can only be generated by a generator, okay? Remember, it is not generate. It is just conferred by the generator. So therefore, it should be false, okay? Generates, okay, it will not generate any energy because due to the conservation, the law of conservation of the conservation of energy, okay. Next, an electric iron, in fact, it will give out thermal energy when it switch on. So definitely it will give out the thermal energy, okay. So please help me to do the correction, okay. Next, okay, which of the statement about the energy it will be correct? Most of you get it correct. It will be C. Next, when a ball roll down a slope, so it will gain the kinetic energy, but not potential energy because it is lower the position. That means the position it keep going down. Okay. Next, okay, which of the following energy conversion take place when the arrow is let go? So definitely it is changing the potential energy to the kinetic energy because we are trying to stretch the string. Okay, so when we stretch the string, in fact, we are trying to increase the potential energy. So in this case, the potential energy will be converted into the kinetic energy. Next, a toy piano, as shown, is powered by the dry cell. Which of the following energy conversion take place when we turn the speaker on? So definitely, we are trying to convert the electrical energy into, okay, we need to we need to convert the chemical energy into electrical energy, and the electrical energy, it need to further convert into sound energy. So therefore, the answer should be C, okay? Next, for here, many of you very lazy, just write down the chemical or kinetic or electrical, then done. What means electrical? What means chemical? What means kinetics? You need to mention to me it is the energy, it is the type of energy. So inside the food and also the charcoal, it stored the chemical energy. It is important for you to mention energy. If you could not mention energy, sorry, okay, you cannot get the mark from it, okay. So when the charcoal burns, so this forms, okay, the energy, and the energy, it is converted to what the first one, it would be the thermal energy and also the light energy. Next, okay, the speaker is playing music. So in fact, it is converting the electrical energy into okay, the sound energy. Now, if next time it's saying that, oh, the dry cell inside the speaker, so it should be converting the chemical energy to the electrical energy first, and that electrical energy towards to the sound energy. Okay. Then the bird flies up to the tree. So in this case, okay, it is trying to convert the chemical energy inside the body to convert into both kinetic energy and also potential energy. Now, when the balloon is released, okay, something stored in the balloon is converted. Mainly, it is the potential energy. The potential energy will be converted into kinetic energy and also the sound energy. So we can see, okay, if you did not write down the energy, please help me to write down the energy, okay? Then next, okay, for this one, many of you do, okay, write the correct parts, okay? And remember, this is E, or it is not the boiling water, it is the boiler, okay? It is a structure that you will see in the coal-fired power station, okay? Next, okay, what is the function of part C and also part E? For part C, it mainly drives the generator, but it does not drive the turbine. It is two different things, okay? So it only drives the generator, but not drive the turbine. Next, for part E, it changed the steam back to water, okay? Next, okay, for the part C, in fact, it would be at 3, 1, 5, 2, 4. Okay. Now, how can the energy conversion occur in our power station? First thing, the chemical energy stored in the coal will convert into light energy and also the thermal energy. Secondly, it will convert into thermal and also the kinetic energy inside the steam. Then it will change into the kinetic energy inside the turbine. And later on, the turbine will be converted into the electrical energy. Okay, so this is how 5.1 A and B. Now we move on to part C and also part D. So the unit of the energy include, it would be joule and also the kilocalorie. The total amount of energy in an energy conversion is always conserved, okay? And this is the law of conservation of energy. So we can draw a Sankey diagram to represent the energy conversion. So the energy can be created, but it cannot be destroyed. So it should be false. It should not be created, okay? It cannot be created and it cannot be destroyed. In some energy conversion, the total amount of energy before conversion may be more than that of other conversion. Okay, so in fact, it should be false because the total amount before the conversion should be the same as the amount of energy after the conversion. Electrical energy is created by a generator. Okay, sorry. So electrical energy, it is not created. It is just converted by the generator. In a Sankey diagram, a wider arrow means that there is a larger amount of energy. Yes, that is true. Okay. Now, for this part, question number 2, I've already go through with you. So in this case, I will skip it. Okay, so many of you did not complete the skill practice, but never mind. Okay, for this part, okay, we can see that the solar cells, it will convert 1,000 joule of light energy towards to 300 joule of electrical energy and also 7 joules of thermal energy. So in this case, you will realize that in fact, 1,000 joule and also of light energy, it will convert into 300 joules of electrical energy. And the electrical energy is the things that we would like to have. So therefore, even though it has a smaller amount of energy, but it is the one that it should be going forward, but not having the term because it is not the energy waste. So therefore, the picture, it should be something look like in this way. Okay. the 300 joule of electrical energy should be going, okay? While 700 joules of thermal energy, it will be turned, meaning that it is the waste energy. Is that okay? So please help me to copy it down to the correct answer if you did not done it, okay? So for tomorrow's homework, what will it be, okay? Page 41 to page 45, okay? Page 41 to page 45. So you may work on, okay, um, uh, work on it, okay, quietly during the remaining time because I will not go through any other things. But please help me to complete the workbook, page 41 to page 45, okay? So if you have any other questions, feel free to ask me on Wednesday, okay? So please work on the homework and the homework, it will be due on Wednesday.